Okie doke. Question 1.4. And finally, a straightforward question where we're actually going to work out optimal policy. So, Vattenfall, or waterfall, produces electricity and emits pollutants, which have a negative impact on air quality. And waterfall's cost function is this. I can get the lid off my pen. Costs are a function of quantity and emissions, and it's C plus Q minus E squared over 2, where C is just a constant. And the demand function is P equals A minus BQ. So we've got a super simple demand function where A and B are just constants. But what's the benefit function? Well, the social surplus S, which is a function of Q, is the integral under the demand function, isn't it? The integral between 0 and Q of P of V dV. So here we're being like proper mathematicians and not using Q here and here. Okay, but you can think of this V as the Q, yeah? Because P is a function of one variable, and this is the same variable here as here, yeah. Okay. So what does this integral work out to? It must be, if you integrate this, you get A. Now we've got V, so it's A minus BV. Integrating, you have AV minus BV squared over 2. Put in, let's do it, A times V minus B times V squared over 2 between these limits. Put these in and you get AQ minus BQ squared on 2. So that is S of Q, the surplus. So this is nice, I like this. What's going on here? It's something like this, isn't it? As Q goes up, the surplus is going to go up with this, but then later this is going to dominate, and it's going to go. Okie doke. Oh, hey, damage is linear in E and is equal to delta E. So if we had, am I still on camera here? No. If we had E here and dollars per ton here, then damages would be like this, wouldn't they? At a level delta. And what are the benefits of emissions? Well, if we remember our theory from before, the benefit curve could look something like this, couldn't it? And we're going to be looking for wait. Cut. We're looking at total. If we're in the context of our previous, the theory stuff, then this is emissions, yes, but this is in total benefits. It's like dollars per year, and the cost curve is going to be like that with a slope of delta, the benefit curve is going to be something like that, and we're looking for this point, aren't we? Sorry. Okie doke. So we're going to assume that Vattenfall is a price taker. So it's as if there's a perfect market, even though we've said that Vattenfall is alone on the market. What's the uncontrolled level of emissions for a given amount of energy produced? So to answer this, we need to set up the firm's problem, don't we? What is the firm's problem? The firm's problem is to maximize price times quantity minus costs, isn't it? Plus and minus any taxes or anything, but we haven't got any taxes right now. So max by choice of Q and E. And pi is, so what have we been told again? We've been told that P is A minus BQ. Times Q minus costs, which is minus C plus Q minus E squared over 2. So this is the firm's problem, I do believe. And we're going to take first order conditions in Q and E. So what does the first order condition in Q yield? So this is minus BQ, AQ, that goes to A, minus BQ squared goes to minus 2BQ, and here we have minus twice this over 2, so it's minus this, go inside and differentiate the Q, you just get 1, so it's minus C plus Q minus E equals 0, so we can write that. And the first order condition in E, well, that's really straightforward because E doesn't affect Q apparently. It just affects costs. Yeah, in this way of formulating it, of course, E only appears here in the cost function. And what do we have then? Doing the outside, we have minus 2 times this over 2, so it's minus this. Going inside, we get minus minus 1, so it's plus this. So C plus Q minus E equals 0. So basically the firm is going to set E equal to C plus Q to make sure that there's no costs, which is a bit odd, but whatever. The firm doesn't have any costs at all at that rate. So when that is naught, we have that Q, A minus 2BQ is naught, so 2BQ is A, Q is A over 2B. Let me just have a check of my crib sheet. according to my crib sheet, I got it wrong again. Sorry. Where did it go wrong? Let me pause. Okay. That took me a while. Who spotted my deliberate mistake? The mistake I made was forgetting that the firm is a price taker. So it's this weird setup. We've only got one firm, but it's a price taker. It treats the price as exogenous. So this is wrong. As the firm sees it, its revenue is the exogenous price times the quantity. Okay. And this is costs. So when we differentiate this, we get P, and then this, with respect to Q, we just get P. And what's P? It's A minus BQ. Now we can put in A minus BQ. So then we get, from the first order condition in Q, we get A minus BQ is equal to C plus Q minus E. And from the first order condition in E, we get C plus Q minus E is naught, and we get Q is A over B, and E is C plus Q. So C plus A over B. So let's put that over here. Social planner, Q equals A over B, E equals C plus A over B. I'm going to pause again. Sorry, that wasn't the social planner. Yeah, that was the free market laissez-faire. Now to the social planner. So what's the social planner's problem? The social planner wants to maximize net benefits. And what are net benefits? We can call them something, I don't know. Let's call them pi star for the social benefits. We want to maximize pi star, which is the surplus AQ minus B over 2Q squared, we worked that out earlier, minus costs, which is C plus Q minus E squared over 2. But of course, it's kind of obvious when you see what's going on. We're going to choose E to make sure this is 0, and it's not going to play any role. And we're just going to choose Q to maximize there. So it's super straightforward. But let's go through it anyway. So the first order condition in Q gives us A minus BQ equals 2 over 2, we get rid of that, C plus Q minus E. It's exactly the same as in the free market case. And the first order condition with respect to E gives us 2 minus C plus Q minus E equals naught. But again, I made a deliberate mistake. What was it this time? I forgot damages, yeah. And what are the damages? They are minus delta E, aren't they? Minus delta times E, which isn't affecting the first order condition in Q, but it is affecting the first order condition in E, because we end up with twice this, cancels, minus minus cancels. That should actually be plus minus delta equals naught. So now we have that. C plus Q minus E is equal to delta. So putting these together, A minus BQ equals delta. Q is A minus delta over B. Let me check my crib sheet. It's looking good. And emissions then are, well, EC plus Q minus delta, aren't they? So it's C plus A minus delta over B, EC plus Q minus delta. Maybe we could simplify that. No, perhaps not. And I'm going to pause again. Okie doke. And finally, I think I'm running out of time on my memory, which is a bit weird. But very quickly, the uncontrolled level of emissions. Here, E is C plus A over B is clearly greater than the social optimum, which is obviously what we'd expect. And I think this is about to die.